Hi everyone, I'm just getting things ready to take a look at this next video in our unit on sequences and series. What we're looking at in this video is section 1.2, the arithmetic series. We'll be trying to understand, first of all, what is meant by the arithmetic series, figuring out a formula that we can use, and then using that formula to practice a couple different sample questions. In terms of vocabulary, make sure you're looking for just the arithmetic series. What does it mean? And what do we need you to understand when we say the arithmetic series as you talk about it with your classmates? So first of all, we're going to take a look at a mathematician, a German mathematician named Carl Friedrich Gauss. Gauss is actually responsible for developing this formula that we call the arithmetic series. And the story goes that when he was a little boy, he was 10 years old, that his teacher asked him, "What is the sum of the numbers from 1 to 100?" So Gauss supposedly played around with this idea and came up with what was a very neat and tidy way to figure out this sum without going to a lot of tedious work like writing down all the numbers from 1 to 100 and adding them together. He found another pattern, and this is what he did. He took all of the numbers from 1 to 100 and added them up in a long row. And he didn't actually write them all out. He just imagined that this is what he was doing. And then he said, well, suppose I do the same thing but backwards. And so if I were to do that, every one of these numbers, if I were to line them up and look at what they add up together to be, they add up to 101, the same as the first term and the last term. And if I think about it, I actually have 100 101s. So the question would be, what do you think Gauss would do now? Well, you see, he's listed two of these numbers, 1 to 100, twice. So what he did was he took 101 and multiplied it by 100, but then he divided it by 2 and got an answer of 5,050. So it's a very simple, streamlined, clean method of adding up a string of numbers. Let's say we try it one more time, and this time on this total length of the spiral. We've got a 1, we've got a 2, we've got a 3, and a 4. So what if we took all those numbers and added them together? Let's try Gauss' method. Well, if we do that, it goes all the way the numbers to 14. The last number in the pattern along here, if you pause the video and count, is 14. So he's adding all the numbers from 1 to 14. Let's turn it around and do 14 to 1. And if we take a look at what happens when we take the first term and the last and add them, they add up to 15. So there would be 14 15s. And since I've done this series or this string of numbers twice, I'm going to divide by 2 to find my answer at 105. This is what we call Gauss's method of calculating a mathematical series. What is a series? Well, an arithmetic series is a sum of terms that form an arithmetic sequence. In other words, you simply take the numbers in the sequence and you add them together. So the question is, can we come up with a formula that will work for any arithmetic series? Well, I'm going to pop into a proof that I have that's written here so that I can use it a little bit, and we'll talk about it a little bit. In terms of understanding this proof, what we want you to be able to do is to follow along and sort of understand the general gist. We would never ask you to repeat it, but we want you to start to get used to deductive proofs like this one. So here we have it. We're going to write our arithmetic series as the first term plus the second term plus the third term plus the fourth term, all the way through to the last term. Now, that's not a really helpful way to write this series. So now I'm going to write it in terms of the first term. The first term is okay, but the second term is the first term plus a constant. The third term would be the first term plus two constants, and so on all the way down till you get to the very last one. And the last term we know is the first term plus n minus 1d. So I'm writing my series in order. And now I'm going to take the same thing and write it in descending order. And then I'm going to add them from top to bottom. So if I add these guys together, I'll have 2t1s plus n minus 1d. And it happens that if you do that to the next one, you get 2d1s and then you get n minus 1d. It happens on every single one of them. And if you think of all these terms that you're adding up, just like we did in the others, you have n numbers of them. And so really what we've found then, because of course there are two of these series together, and so we don't want to know 2, we don't want to know 1, so we divide by 2. And we have this thing that it adds up to. If I separate this for a minute and separate the T1 and the T1 and group them a little differently, can you see that this is the last term, the formula for the last term? So here you have it, your formula for the arithmetic series. N, the number of terms, divided by 2, times the first term plus the last term. And that really is as simple as it gets. Now let me go back to the PowerPoint and we'll see if we can follow along a little bit. So here was the formula as Gauss discovered it. This was the original one before he split up the T1s. And then we write it this way. That is the cleanest and easiest way for us to remember it and to write it. So now we're going to take a look at a few problems and see if we can understand what's happening. First of all, we check to see if it's arithmetic. My first term is -3, and it looks like I'm adding 4 to each one of these numbers. So let's take a look at the actual solution. We know if we list all our terms that the first, our constant is 4, the first term is -3, and we are not sure actually how far we're going to go. We do know that our last term is 29, so we'll figure that out later. So now we want to find out how many terms this guy actually is. So I need to know what is that term. And so I put it in as 29. Oh, I think I must have highlighted this out. This is a -3 plus n minus 1 times the constant, which is d. Here's your -3 there again. Sorry, he's kind of invisible. So then 29 equals 4n minus 7. I add a 7, divide by 4. Turns out this is the 9th term. This guy is the 9th term. So now let's go back to our formula. The sum of 9 terms is 9 divided by 2 times the first term plus the last term. And you use your calculator and set it up, and you'll find your answer is 117. Let's try another one. And you'll notice with this guy that our first term is 1/2. And then it's a little hard to see. If you think of this as 4/4, it's a little better. So 1, 3, hang on, 4/4, 5/4, 6/4. There's actually, I didn't realize that. Oh, sorry. This could be written if we write everybody as a denominator of 4. Actually, that's a good mistake to make because you might do it too. If I made this as a denominator of 4, it's 2/4. And then I could see everything's changing by simply 1/4. 4/4, 5/4, 6/4. It's all changing. So let's take a look at the next part. So rewrite it with a common denominator first. Your first term is 2/4. Your constant is 1/4. Now we do have this last term, and we better stop and think about how many terms it is. So we'll put it in. It was actually a 4. So let's use our formula. Let me take a drink here. First term is 1/2 or 2/4. I'm looking for what n this is. And my d, or my constant, is 1/4. I go ahead and expand this, multiply it out, simplify things, and we get 1/4 plus 1/4n. And then if I subtract 1/4 from 16/4, which is what 4 would be, I get 15/4. And so then I can see that my n is 15. Sorry, I went too soon. So now I know the number of terms, so I'll plug it in. 15/2. My first term is 2/4. My last term is 4, or 16/4. And go ahead and simplify stuff, and you have your answer. Okay, to determine the sum for the arithmetic sequence described here. This one's nice and straightforward. They give you the first term, the number of terms, and the 8th term. So you actually, the only thing you need to know is the constant, but really you don't even need to know that if you're going to do the series. So the sum of the first 8 terms is the number of terms 8 divided by 2, the first term plus the last term. And again, use your calculator to find your answer. Okay, just double checking to see if this is arithmetic. It looks like I'm adding 2.5, 2.5, 2.5. Good. So they want us to find it all the way to the 42nd term. So first term's 1, constant is 2.5, and the number of terms is 42. Before I go anywhere, I think I'll stop and figure out what the 42nd term is. So I take my first term plus, that's not plus or minus, but just plus, 42 minus 1 times the constant, and that gives me 103.5. So the number of terms is 42, the first term is 1, and my 42nd term was 103.5. for an answer as you see below. Number 4. I know that my constant is 4, the number of terms is 20, but now they tell me the first term. So we're supposed to find the first term. They're telling me that the sum of this series, the sum of 20 terms, is 1,380. So let's see what we got. We want to know, and I've just written it out so I can see it. Now, this one is you are not going to be able to find the 20th term if you try, because all you don't know the first term, you know the number of terms, and you know the constant, but you can't find your information. So let's go to the sum. We know that the sum of 20 terms would be this formula. Filling in what we know, the sum of 20 terms is this. There are 20 terms. We don't know the first term, but we know this last term, we don't know it. Now, what I'm going to do is break this up and write it as the formula, as what it is, T1 plus n minus 1. So that gives me 2T1. And so I'm still looking for 2 T1s. I know that my number of terms is 20 and my constant is 4. And if you look, you'll see, oh, you've only got one variable. You'll be able to figure it out. So pause the video, check your work, and then see if you can take it through and find that the first term is indeed 36. Number 5. So for the arithmetic series, determine the value of n. So they tell us the first term is this, the last term is that. The sum of it all, or the series, is this. So let's see how many terms there are. Okay, so we're going to put it in. We know that the sum or the series is this number. We don't know the number of terms. We know the first term is 2 and the last term is this one. And sure enough, if you do your algebra really carefully, you're going to find that n is equal to 18. Okay, there you have it. That's deriving the formula for and working with an arithmetic series. The homework that we had for this particular lesson is here. And please make sure that you've tried that and bring any questions that you have to class, and we'll take a look at things. Good luck, everyone.